Hi everyone, I hope you're okay and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the third question from the media examination which was written in the province of Gauteng in the year of 2024. Please do expect a total number of 8 videos since this chemistry paper guys had 8 questions in total. And please guys do note that each and every question will have its own video. And please guys do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your media exam, your preliminary exam, and most importantly your final examination. So please do share the video to your peers so that they may have the same edge as you. And please guys do help us grow the channel by just subscribing. Okay, a group of learners decide to conduct an investigation to compare the boiling points of the first 3 haloalkanes, namely chloromethane, chloroethane, and 1-chloropropane. Okay. The table below shows the results obtained from the investigation. Compound A is our chloromethane that has a boiling point of negative 24.2 degrees, and then chloroethane has a boiling point of 12.3 degrees Celsius, and then 1-chloropropane has a boiling point of 46.6 degrees Celsius. Okay, this guys simply tells us that the more we increase our chain length, our boiling point increases. Are you together? So our dependent variable over here is the chain length, and our independent variable rather is the chain length, and the dependent variable is the boiling point, because our boiling point depends on the chain length. Are you together guys? And then obviously you can say the control variable over here is the homologous series. Yeah, it's the homologous series. Okay, let's answer these questions. Define the term boiling point. Boiling point guys is just a temperature at which the vapor pressure of a liquid is equal to the atmospheric pressure. The temperature at which the vapor pressure of a liquid is equal to the atmospheric pressure. Okay, the independent variable is the chain length, as we just said. The dependent variable is our boiling point. And then 3.2.3, the controlled variable is the homologous series, because all of these compounds guys, they belong to the same homologous series. Are you together? And then they want us to write down the suitable investigative question. It will simply be how does an increase in surface area affect the boiling point? Are you together? How does how does an increase in the chain length affect the boiling point? Okay, please make sure that guys your investigative question on your investigative question you must mention both the independent and the dependent variable. Are you together? Just find the relationship between the independent and the dependent variable. Okay, we are told that chloromethane is highly flammable. Which one of the precautions that should be taken when working with this substance in a laboratory? Just move it away from open flames, or if you have to burn it, or rather if you have to heat it up so that it can react to form other organic compounds, please do heat the chloromethane inside a water bath. Just to prevent it to turn into flames. Which one of these substances, A, B, or C, has the lowest vapor pressure? And give a reason for your answer. The one that has the lowest vapor pressure is the one that has the highest boiling point. So C has the lowest vapor pressure, right? So the reason is because compound C has stronger intermolecular forces compared to the other two compounds. And then we are told that learners find 1-chloroputane in a laboratory. How will the boiling point of 1-chloroputane compare to that of the boiling point will simply be higher than, and then now we must give a reason for our answer, ne? Okay, I can answer this question by mainly by making the chloroputane as my point of reference. Are you together? If I make chloroputane as my point of reference, I'll simply say point number 1. 1 chloroputane has a greater surface area than 1 chloromethane. You can say 1 chloroputane has a longer chain length than 1 chloropropane, guys. We are comparing chloroputane and chloropropane. Okay, and then this simply means that 1 chloroputane has stronger intermolecular forces compared to 1 chloropropane. 1 chloropropane, ne? So this simply means that 1 chloroputane requires more energy to separate the bonds. And hence 1 chloroputane has a higher boiling point. Whenever, guys, you have to explain the difference in the boiling points or maybe vapor pressure or something, ne? Please, guys, do mention the first thing you have to do. Mention the difference between the two compounds. In my case, I said chloroputane has a greater surface area than chloropropane, ne? Or you could have said chloroputane has a longer chain length than chloropropane. Are you together? That's the difference between the two compounds. Secondly, tell us which one of the two compounds have stronger intermolecular forces. The one that has a longer chain will have stronger intermolecular forces. Are you together? And then thirdly, tell us about the energy required to separate the bonds. Obviously, if your compound has stronger intermolecular forces, it will require more energy to separate the bonds. And then the fourth point, you should comment on the boiling point. Are you together? In this case, they asked us about the boiling point, and I know that the compound with stronger intermolecular forces will have a higher boiling point. So that's how, guys, you explain by referring to the intermolecular forces, strength, and energy as well. Okay, and then 3.8, learners decide to do another investigation with compounds J and K. Compound J is just but2-in, compound K is butane. So compound J compound J is just, where is this pen? Compound J is just a compound that has a double bond, né? So compound J is unsaturated. Are you together? But compound K is saturated. So let's see where does this lead us. We are told that bromine water is used to distinguish between compounds J and K by adding to each compound in 2 separate test tubes. Okay. The learners observe that one compound decolorizes in bromine water immediately, while the other while the other substance only reacts after placing the test tube in direct sunlight. Okay. First question. The letter J. Write down the letter J or K for the compound that will immediately decolorize in bromine water. J is the one that will immediately decolorize. Are you together? Why? Because it is unsaturated, so it will just react spontaneously with bromine water. Are you together? You don't even need sunlight for compound J to react with bromine water. Okay, and then the reason that the other substance only reacts when placed in direct sunlight is because, guys, butane is saturated. Are you together? So it has stronger intermolecular forces than compound J. Are you together? So for us to make sure that compound K reacts with bromine water, there must be an increase in temperature. Are you together? There must be an increase in temperature, guys. Né? So we must heat up the test tube or probably use direct sunlight to heat up the test tube. Okay, and then they want us to write down the molecular formula of the organic compound produced. Write down the molecular formula of the organic product formed in the test tube that containing compound J. Né? Guys, you're simply adding, you have an alkene over there. You have an alkene, it has hydrogens. You're just reacting with the bromine water. Obviously, guys, your product will simply be 1, 2, 3, 4. The first thing that you should know is that this double bond will just break. We'll end up having single bonds between adjacent carbons. Since we are breaking those two bonds, that means we'll end up having bromine over there and bromine over there. So the molecular formula of our molecular formula will simply be 4 carbons, C4, H8, and then Br2. This will simply be our molecular formula: C4, H8, Br2. And then now they want us to write down a balanced chemical equation when compound A undergoes complete combustion. If, guys, your compound undergoes complete combustion, just know that our butane, which is C4H10, will be added with oxygen, and then our product will simply be carbon dioxide and water. Always the time, guys, for complete combustion, these are your products. By just writing this statement, guys, you already have 2 marks out of 3. And the other mark is just for balancing. Né? Okay, let's try to balance this thing. How many carbons I have on my left hand side? I have 4. I also have 4 carbons over there. The number of hydrogens I have on my left hand side are 10, but I only have 2. So I know that 5 multiplied by 2 will simply give me 10. Let's find the number of hydrogens, of oxygens rather. I have 4 times 2, which is 8. 8 plus 5, that's basically 13. Are you together? So whatever number I write over here as a coefficient, it has to be half the number of oxygens that I have on my right hand side. Since the number is 13, so half of 13 is basically 13 over 2. Are you together? Yes, this thing is balanced, guys, but we should not write our stoichiometric coefficients as fractions. Né? We must write them as integers. Are you together? So how can I remove this denominator over there? How can I remove that denominator? If I can multiply each and every subscript over here by 2, I can simply remove that denominator. I'll end up having 2C4H10 plus 13O2, which will give me 8CO2 plus 10 H2O. I would get. Now this equation of mine is balanced because I have 8 carbons on the left hand side, 8 carbons on the right hand side, 20 hydrogens on my left hand side, 20 hydrogens on my right hand side, 26 oxygens on my left hand side. I have 16 plus 10, which is 26 on my right hand side as well. So this is my balanced combustion reaction of butane. That's how, guys, you could have tackled that question to get your full marks. So please do stay tuned and wait for more videos. Thank you.